Hello. Lesson 64, which would have been done on Thursday, March the 19th, in the afternoon. I'll just put PM. Afternoon, not evening. Afternoon. Okay, and it was about differential equations. So differential equations are equations that where you've got an equation. This one is you've got an equation with a derivative in it. So you've got something like dy by dx is a function of y times a function of x. Okay. Now there's lots of different types of differential equations, but the ones that we're going to look at in this lesson are ones like this, where you've got a function of y definitely multiplied by a function of x. Now what we do here is they rearrange it so that you get the function of y, you bring that to the left hand side. It could be the function of y, it's whatever letters up there, because that's dy, it's f of y. So here is on that side, but we bring it over here. So we can say it will be 1 over f of y dy dx is g of x. Okay? Or if it was 1 over f of y on this side, it would be f of y up there. I'll just put that in as an or. Or if you've got dy by dx is g of x divided by f of x, we can have f of y dy by dx equals g of x. So you either divide or multiply by the f of y, depending where it is, whether it's in the numerator or a denominator on the right hand side. Okay. And then what we do in this step here, if we integrate both sides with respect to x, okay, and if you can imagine using the chain rule, they cancel. So we end up with the integral of f of y dy equals the integral of g of x dx. Okay, hopefully that'll become clearer with the example. I think sometimes when it's all the letters it gets a bit much, but the examples are what you need. Right, so example 1, find the general solution of the equation dy by dx is 2x times y plus 1. That should be minus 1, so it's y greater than minus 1. Looks like it's, just show you what it looked like. It sort of looks like a funny symbol there. That's not a math symbol, that's a greater than 1. Let's just cross that bit out. Okay, so we've got two functions multiplied together. We've got 2x and y plus 1. So we're actually in this one here. We've got an f of y times a g of y. Okay, so we collect the y's to the left. So it's going to be 1 over y plus 1. dy by dx is 2x. And then, put that there, is a bit nicer there to use actually. Integrate both sides with respect to x. Integral of 2x dx. And they cancel. Well, don't really cancel as such, but we can think of it for maths, A-level maths. So the left-hand side, we've got ln y plus 1, because the integral of 1 over y plus 1 is ln y plus 1. The integral of 2x is x squared. I'll put the constant of integration there. So to undo the ln on the left, we do e to the right. And then if we let a be e to the power c, we can say y to the power 1 is a e to the x squared. Okay, and that's come from, this is e to the power c here, there. I'll just put that there because it's not really part of there. Oh, and we can finally say y is a e to the x squared minus 1. Change the colour because I just find this a little bit, nice different colours. Okay, right, so next for part B, we've got x is 3, y is 0. It says find the particular solution given that x is 3 when y equals 0. There. X is 3, y equals 0. That's the bit that I homed into. We substitute x is 3, y is 0, and it will give us what the a is. So x is 3, y is 0. So we end up with 0 is a e to the 3 squared minus 1. So therefore a e to the 9 equals 1. So a is equals to 1 over e to the 9, 1 over e to the plus 9, which is e to the minus 9. I'm just thinking ahead there. So substitute this back in the peachy coloured box. We have y is e to the minus 9, e to the x squared minus 1, which we can simplify as e to the x squared minus 9 minus 1. Okay, so the peach colour that I've got already, that's the answer there. And then I need another colour, that one there, and that one is the answer there. Okay. Right, example 2. Solve dy by dx is 2x, I'll just zoom in so you can see that, over y, square root of y squared minus 1, given that when x is 2, y equals 1. So again, look, we've got y's up here. So I want these y's, this is x's divided by y's. So I'm going to multiply both sides by the y's, leave the x's there. So y square root y squared minus 1 dy dx is 2x. Integrate both sides with respect to x. Think of those as cancelling. We know what the integral of 2x is. That's x squared plus c on the right hand side. We've got to think about, I'm just going to do this as an aside down here. We need to think about the integral of y square root y squared minus 1 dy. So when it's like this, now you can think of the square root sign as like being treated like a bracket. So sometimes you've got a sine of a bracket, cosine of a bracket, square root, e to a bracket, log of a bracket. The square root, we can treat that as a bracket. And what we do, because the power of y inside the bracket is 1 more than the power of y outside the bracket, or outside the square root sign, what you can do is you make a substitution. U is y squared minus 1. Okay? So think about what we've got now. We've got the integral. We haven't done anything with that yet, but this is now a square root of u. So we've still got to do, when we're going to substitute for u, we've got this u to the power of half there. We've got to deal with the y and the dy. To deal with those, we differentiate both sides with respect, well, du, we'll differentiate u with respect to y. Gosh, I'm trying to get comfy here. Oh, get used to this couch living with this coronavirus lessons. Right, behave yourself. Right, du dy is 2y. So we need a y dy, and look, you see, you can have du is 2y dy. So therefore we can have, that's what I did there, multiply that y up there. So y dy is du over 2. Okay. So on this back to this bit here, now we say the integral, right, root y squared minus 1 is u to the power of half, or root u. The y dy that's left is a du over 2, and I put the 2 over there, and that's x squared plus c. Okay, so we've got to integrate. Now this is just add 1 to the power, divide by the new power, and multiply with the 2 that's there already. And I'm just going to leave the c that we've got already. There's the c there. The 2's cancel, and then we'll rewrite u to the power 3 over 2 over 3 plus x squared plus c. Thought it was the end of the story, but it's not, because we've got x is 2, y is 2, and that's going to help us find the c. Oh, when we replace the u as well. Let's put the u back. U was y squared minus 1 y squared minus 1, 3 over 2, 3 over 2 over 3, x squared plus c. I'm going to work out this c now. So we've got to substitute. X is 2, y is 1. So on the left we've got 1 squared minus 1, 3 over 2 over 3. X squared is 2 squared plus c. Well look, this 1 squared minus 1 here, that makes everything on that side equals 0. So therefore 2 squared plus c equals 0. So therefore c is minus 4. So finally, we can go back, put the c into there, and we'll have y squared minus 1 to 3 over 2 over 3, x squared minus 4. Let's get that a nice new colour, nice yellowy colour. There we go. You could rearrange that a little bit, but I don't think it's going to ever look particularly pleasing mathematically. I think that's what it is. Right, the next one. In 1820, Thomas Malthus suggested that the rate of growth of population P over time T is proportional to the size of the population. There's no numbers there apart from the year, which doesn't come up into the differential equation, so it just is what it is. We need to express this model. We're going to end up with all letters, what I mean by that. Express the model using a differential equation, find a general solution, consider the limitations of the model. I know C already. The limitations of the model, when it's rate of growth, it's going to be like resources. The limitations are, have you got an infinite supply of the resources that you need? Probably not. So it's going to be, it'll be like resources, e.g. it could be food, habitat, environment. Sometimes these questions are used for like bacteria in a petri dish. Well, eventually the space runs out, so they can't keep growing forever. Okay, so when it's population growth, you almost it's like almost like a sort of standard answer. Resources may be limited. Okay, so I'll just put that there. Right, just put that down. Right, let's look at this sentence here. Rate of growth in mathematics, rate of growth is dy by dx. Now, because it's actually p, it's dp by, and it's p and t. Okay, because it's the rate of growth of the population p over time. So it's got to be dp by dt. Order is important. Is proportional to the size of the population, which is p. Okay, let's give that a colour as well, because that's quite important. Let's go along, we'll go to the green now. Is proportional to, is that one there, and the size of the population is p. Okay, so all the bits from the sentence are coloured in to what it needs to be. So we can say dp dt, this is from GCSE, proportional to is equals k times p. And then like we had before, we had dy by dx's, and we put y's on the left, and it was because it was a y up there. So because there's p's there, we want the p on the left. So we can say 1 over p dp dt equals k. And then we're going to integrate both sides with respect to t, which I've sort of taken a shortcut there, and then do that as well. So end up with ln p equals kt plus c, because the integral of k with respect to time is kt. That's c plus c. What am I doing? I'm okay there. Ln on the left, e on the right, and then the plus c part, we can say p is a e to the kt. Okay, so this part here, that's where part A finishes, and this is where we start with part B. That's the answer for part B. Yeah, there we go. And then part C, limitations, is always that things aren't going to grow as long forever. Right, example 4. A species of tree is expected to grow to 10 metres in height. So it starts at t equals 0, h is 0, and at some time in the future, we don't know what t is, but h will be 10. The rate of growth in metres per year is directly proportional to the height it still has to grow to reach its potential. The rate of growth can be modelled by dHdt equals. Right, okay, so what we've got here, let's go for blue. Rate of growth is dHdt. Can you see that? I wonder if that's big enough. The rate of growth, well, growth is metres or height in time. The rate of growth is the difference in height over the difference in time. Metres per year, look. Metres is the H, year is the T. Directly proportional to, well, that's from GCSE. Directly proportional to, that's equals K. You always have that symbol. You have that like symbol that looks like this. And then you replace it by equals K. There was one in the previous example, that's got messy. Is proportional to is like that, but then you replace it with equals K times on the next step. And the height, it still has to grow to reach its potential. Well, it wants to be 10, and it's still got to grow 10 minus h. So if it's 6, it's still got to grow 4. The height, it still has to grow, so it's 10 minus 6 is 4. So it's 10 minus h for that bit there. Okay, solve the differential equation. It's got dH dt equals k 10 minus h. So if you see, h is on the top there, so those h's want to be over there. Whoops. So therefore, 1 over 10 minus h dH dt equals k. Now, what we're going to do here, I'm going to multiply both sides by minus 1. Okay, and the reason being is because I don't like this minus h. I think that's what I'm going to do anyway. There's a few ways to solve this. So this minus h, if I multiply this by minus 1, I could multiply top and bottom by minus 1 and it leaves it unchanged. I'll do it that way. Multiply top and bottom of this fraction by minus 1. So we can have minus 1 h minus 10 dH dt is minus k. No, too far. That's the next step. Still plus k then. I'm doing 2 steps in one of that in my mind there. So what I'm doing here, look, to keep an equivalent fraction, top by minus 1, multiply this by minus 1, so 10 becomes minus 10, minus h becomes h. Okay, and now I'm going to integrate both sides with respect to t and put the minus sign outside the bracket, like so. They're going to cancel. Integral of k dt. So this is minus ln h minus 10 equals kt plus c. Right, then we've got just thinking what to do with the minus sign. We'll just put it in as a power. Leave it there. I'm going to multiply both sides by minus 1. Ln h minus 10 is minus kt. And this one constant because it's being multiplied by minus 1. I'll just call it c and change that to c1. H minus 10 is e to the minus kt plus c, which is a e to the minus kt. And then h is going to be all that plus 10. Okay, so that's that question. There's quite a lot in that one there. That's part A. That's the answer to part A there. Next bit. B. After 2 years, t equals 2, h equals 1. Find the particular solution. Now for this one as well, this is why I put this up here, t equals 0, h equals 0. Because we've got 2 unknown variables in here. We've got the a and the k that we need to find. We've got a t and a h. A and 10's fine, and e is fine. So we need to find the k and the a. So we've got to substitute in not only t equals 2, h equals 1, t equals 0, h equals 0 also. I'm going to do that one first. So let's do this one first of all. 0 is a e to the 0 plus 10. Okay, so what I've done there, h is 0, t is 0, well k times 0 is 0, and then plus 10 is 10. So therefore a, because e to the 0 is 1, a times 1 is a, so a plus 10 equals 0, so a is minus 10. So that's the first one. So now I'm going to substitute in the other bit. T equals 2, h is 1. So we get 1 is a, which is minus 10, e to the minus k times 2 plus 10. Okay, so h is 1 there, t is 2, t is 2 there, minus k, e, a minus 10 from there, plus 10. Plus 10 is part of the equation. So therefore, take 10 from each side, minus 9 is minus 10, e to the minus 2k. Divide both sides by minus 10, so 0.9 e to the minus 2k. E on the right means ln the left. Ln 0.9 is minus 2k. So therefore k is ln 0.9 divided by minus 2. I'm doing it again. K, let me just get my calculator. I've got this worked out already. K is 0.0. I've got it worked out already because it went wrong before. So that's something I've got to get used to. Anyway, so eventually we have, what have we got? I've got my K, got my A. So the height is A, which was minus 10. E to the minus kt, minus 0.053 t plus 10. Yeah, there we go. Oh, and end of the pastel colours, so let's go to pink for that one there. Pink there, and that's for that one there. I've also used all this information there, that information as well. Right, ran out of room for part C. It's the last one. Oh, I can put, let me just do this. Let's just colour this in. What have I got? A white colour? Yes, I have. Let's just colour that in white. No. White and large. Well, I don't believe that. I'm sure that works before. Anyway, right. Next page then. H is, no, let's do plus the page. I'll just finish this off. H is minus 10 e to the minus 0.053 t plus 10. Now the question for part C, if you look, it says use the model to predict the age of a tree that is 6 meters tall. So we need the T, and we've got the H is 6. So H is 6, and find T, which is the age. Okay, this is part C. So substituting in 6 minus 10 e to the minus 0.053 t plus 10. Subtract 10 from each side, minus 4 minus 10 e to the minus 0.053 t. Divide both sides by minus 10, that's going to be plus 0.4 e to the minus 0.053 t. E on one side, ln the other, so I'm going to do that. Ln 0.4. Okay, divide both sides by, and I've rewritten it into a more natural form, minus 0.053, which is approximately 17 years. Okay, so I think that one's in grey on the previous page, so that's the answer, 17 years. That I wouldn't put into an exam because it would just take too much time. Okay, it's still interesting maths, very interesting maths. The uses for this are amazing. Right, that'll do for that one then.